When we make the movement of the object, rather than moving permanently, it's better to have some boundary to control the agent. So here, we're going to create the boundary and then make the object only move inside of this boundary. First of all, I'm going to create the cube and we'll name this as bouncing agent. And let's reset the position and then go to the script folder. Let's create a C# script which is called bouncing agent as well. Basic idea is same as when we just did moving object. So first of all, let's make object move. Previously, we created private vector inside of the update, but this time we're going to create private vector outside of the update, but still inside of the class to develop later. Now we know that we're gonna need position vector and as well as velocity vector. This time I'll just gonna call it position vec and velocity vec. And just to update velocity vector, we're going to use velocity number. And this is going to be the speed of the object. And this time, we're going to declare these two vectors inside of the start. So before we update every vector, there is going to be the start point of these vectors. Position vector is okay to be with just 0, 0, 0, which is going to be the start position. And velocity vector is going to use velocity number. And we want to check x as well as z. So I want to use velocity number at j location, at j position. And this time we need to check x and z in the same time. So I will use this velocity number inside of the z as well. But to avoid move directly 45 angle, so I'm gonna just divide it by 3. So same as before, we need to update position vector with velocity vector every time, and then we need to say this position vector is going to be the position of transform. Now position vector is updating by velocity vector. In the end, position of the transform updated with position vector. So now it's going to move exactly same as before. So just to check this script is correct, let's go back to the Unity and let's attach our bouncing agent to bouncing agent. Now it is working correctly. But to see this movement in better way, let's look at this from top view. So I'm gonna click this Y view, and now we're gonna look at this from top. So to give them boundary, what we need to do is just change the vector of the object when it leads to the boundary. For example, it goes to this way, and then when it leads to here, the direction of this object need to be negative, so it can go the other way. Here, we need to have some specific condition. So in that condition, the velocity is going to be negative. So if something is true, the velocity is going to be negative. The vector need to be treated separated way, x and z. So first of all, we need to check x boundary, and then we need to check z boundary. So inside of this if condition, we need to check if the position of this object went outside of the boundary or not, but we need to separate x and z. So first of all, position vector dot x means x location if this is larger than some specific boundary, let's say boundary x. Well, we didn't create the boundary x value, so I'm gonna declare the public value, which is going to be boundary x. And I will also create the boundary z as a 10. Not just checking the when it goes upside of the boundary, we also need to check downside of the boundary. So what we can say is if position vector x is smaller than minus boundary, now the velocity should be negative. But now we are writing the same thing 2 times. In this case, we can write this one a bit smarter way. I just wrote down the 2 vertical bar, and this means or. So in this if condition, it's going to check both cases, if x is larger than boundary x or if position x is smaller than minus boundary x. Either case, the velocity vector is going to be negative, and this goes to same as z. And in here, I didn't give the direction of velocity vector, so we also need to have the direction of the velocity. So in the case of when check the position x, we need to change the x velocity. In the case of we check the z axis, we need to change z velocity. Before we test, let's make some kind of background to see more clearly. So I will create 3D object plane. And let's call this one as ground. And let's reset the position. You can see that the size of the plane is quite larger than cube. When you see this, there's a grid over here, and this one grid means 1 in the plane. Boundary 20 to minus 20 and 10 to minus 10, which means x is going to be 4, z is going to be 2. And I'm going to change the color of the ground. Now you can see that the object is bouncing inside of the just boundary.